Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, Official Guide to the Revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we're about to solve is the one that you will find on page number 228. Please turn to it. Page number 228, problem number 1. And today is our lesson number 316. This problem that you see there on page number 228 is the exact same problem that appeared in the first edition of the revised GRE. We have already solved all the problems from the first edition. If you're interested in watching the original solution, you will find the original solution to the problem on day number 104. Today we're going to redo it at a little bit of a faster pace. So if you need more help, you can watch, as I said, day 104, where we do the same thing at a much slower pace. Here's the problem. Now before I actually put down the problem on the blackboard, let me present to you the answer choices a little bit differently. Answer choices in the book, of course, it's just an open-ended question. They're asking us what's the value of x. Here is one possibility how the answer choices might be presented to you in the exam. So here we go. 1, 2, C, D, E, 2, 3, 4, 5. These are all our zeros. These are all our zeros. And then here we go. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then here are the 5 answer choices. A, B, C, D, and E. The first answer choice goes like this. The second one goes like this. Third one begins from here. And the fourth one here are the 5 answer choices. Our job is to locate the right answer for the problem that is given to us, problem number 1. So here we go. We are told negative 3x plus 5 is less than or equal to 17. Now, the one thing that we have to keep in mind, the only one thing that we need to understand here when one is dealing with an inequality as opposed to when one is dealing with an equality, the only thing that differs here is what happens when you multiply or divide both sides of an inequality by a negative number. That is the only thing that we have to understand. That's the only thing we have to keep in mind. Other than that, everything that one is allowed to do when one is solving for an equation, one is also allowed to do when one is solving an inequality. You can do whatever you like, whatever it is that you can do when you're solving an equality, you can do it the same exact step when you're solving an inequality, except when you have to multiply or divide by a negative number. Let's take a look at it very quickly here. Let's say, for example, would you agree that 10 is less than 12? Of course you would agree 10 is less than 12. Would you agree that 3 times 10 is less than 3 times 12? Of course you would. We just multiply both sides by 3. Now watch what happens. Instead of multiplying it by positive 3, what would have happened if we had multiplied by a negative 3? Instead of a positive 3, had we multiplied both sides by a negative 3, what we would have found here is that we would have a negative 30 here and a negative 36 here. And now we can see the negative 30 actually is greater than negative 36. That is no longer true. That is no longer true. So when we multiply both sides of an inequality by a negative number, the direction of the inequality switches. The direction of the inequality switches. Now let's see what happens when you divide. Let's see what happens when we divide both sides of an inequality by a negative number as opposed to multiplying. Let's see what happens. So here we have 10, and here we have 12. And nobody's going to argue with the fact that 10 is less than 12. Let's divide both sides of the equation by 2. Still, everything is fine. 5 is less than 6, obviously. But what would have happened if we had divided both sides of the equation, both sides of the inequality by a negative 2 as opposed to a positive 2? We would have had 10 over negative 2, which would have given us negative 5. And here, we would have had 10 divided by negative 2 if we had divided by a negative 2. And that would have been negative 6. And negative 5 is no longer less than negative 6. Negative 5 is in fact more than negative 6, this is no longer true. So if you multiply both sides of an inequality or divide by a negative number, the direction of the inequality switches. Let's make a note of it someplace. Let's make a note of it someplace. I shouldn't have occupied this much room here. After we finish the problem, I'm going to make a note of it over there. Let's finish this up very quickly. So we subtract 5 from both sides because we want to separate. We are trying to separate x by itself. Let's subtract 5 from both sides. So this 5 drops out, and here we end up with 3x is less than or equal to 12. Let's divide both sides. Let's divide both sides of the inequality by negative 3. Now notice how I did not simply divide it negative 3 over there, because we did not do it. We did not simply draw a line there, put a negative 3 and negative 3 there, because the direction of the inequality has to switch now because we are dividing by a negative number. That's all. So the negative 3 crosses out with this negative 3, and we end up with x by itself, which we know is greater than or equal to 12 divided by negative 3. 12 divided by negative 3 is going to be negative 4. So what we're saying is that x is greater than or equal to negative 4. X is greater than or equal to negative 4. And where do we see that scenario here, where x is greater than or negative 4? First of all, it has to start with negative 4. And then, right here, this should do it. This starts in a negative territory, and anything that is greater than or equal to this part right here. The answer is B. Now keep in mind that instead of greater than or equal to, if we had a problem like this, where the equal to sign did not exist, you still would have had the same answer, but instead of a closed circle, this would have been an open circle. That's all. So the answer is B. Let's do the next one, shall we? On the same page. Let's make a note of what we just said a little while ago. When we multiply or divide an inequality by a negative number, the direction of the inequality switches. The direction of the inequality switches. We have to keep that in mind. Let's do number 2. On the same page, question number 2, which we are told 4x plus 9 over 11 is less than 15. Is less than 5 rather, not 15. Is less than 5. Somehow we have to get rid of this 11 from the bottom, but lucky for us, this 11 happens to be a positive number. So if you multiply both sides by 11, we can get rid of this 11, and we don't have to worry about switching the direction of this inequality because we are multiplying both sides by a positive number. So that 11 disappears, and what we end up here is 4x plus 9 is less than 5 times 11, which is 55. Subtract 9 from both sides, and you end up with 4x. This 9 drops out, we end up with 4x is less than 55 minus 9. 55 minus 10 is 45, so it's going to be 46. Divide both sides by 4. Again, since we're dividing by a positive 4, since we're dividing by a positive number, we can do it right here because we don't have to switch the direction of the inequality. So the 4 drops out, and x is less than 46 over 4, and 46 over 4, 46 divided by 4. How many 4 in a 4? 4 has 1 4. How many 4 in a 6? 6 has 1 4. And we have a remainder of 2. So a remainder of 2, and we're dividing by 4. So 11 and 2/4. The x is less than 11 and 2/4, which of course is same as 11 and a half. The answer is x is less than 11 and a half. Not less than or equal to, but less than. Which of these answer choices will qualify here? Let's switch this. Let's raise this answer from the previous problem. X is less than 11 and a half. Where can we find something like that? x is less than 11.5. Which of these 5 scenarios would depict that situation where x is less than some positive number? X is less than some positive number, which is right here. Any value which is less than this number, which happens to be 11.5. Even though in the exam they will not actually put the value there. You just asked to locate the right picture, and the right picture is A. That's all. Oh, it's less than, not less than or equal to, so this has to be an open circle. This has to be an open circle. And that's about it. I'll see you tomorrow, where we'll do 2 more problems dealing with inequality just to get some more practice, extra practice, and then we'll move on to something else. Okay? I'll see you tomorrow, okay? Bye now.